Hey guys, Miss Middleton here. Today we're going to start our last chapter of the semester, Systems of Equations. And we're going to talk about how to solve systems of equations by graphing. At the end of this video, you should be able to identify solutions of systems of equations, and you should be able to solve the systems by graphing. Okay, so introduction to our chapter. A system of equations, or two or more linear equations together, form a system of equations. Of equations. Okay, and any ordered pair that makes all equations in a system true is a solution um, of the system. Okay, and so what systems of equations allows us to do, it allows us to now be able to solve for more than one variable at a time. Okay, and typically when we were having problems earlier, we said, well, we can't do this because there's one equation and two variables. And that still holds true. But if there are two equations and two variables, now we'll introduce some strategies into solving both of them. Okay, and before we do that, we'll just look and make sure that we can identify what the solution of a system is. And as it says up here, a solution of a system is just an ordered pair that makes all equations in the system true. So looking down here at this example, it says, is 3 negative 4 a solution of the system? So without learning how to solve by graphing at this point, we can just plug these values in and see, does it make both equations true? Okay, remember, ordered pair, this is x, this is y, we'll plug those in. Okay, we'll plug them into both equations to see if they're true. So here, I'm going to plug in negative 4 for y equals negative, and then plug in 3 for x minus 1. Okay, so negative 4 equals negative 3 minus 1. Is that true? Yes. Okay, so that point makes the first equation work. Okay, so now we'll continue on to the second equation and see if that makes it, or if that's true as well. So again, I'm plugging in 3 for x here, minus negative 4 equals 10. So 2 times 3 is 6. Minus a negative means we're adding. 6 plus 4 is 10. That is true. Makes both equations true. So is 3 negative 4 a solution of the system? The answer is yes. Okay. Alright. And we'll do the same thing for this next problem. Again, remember, it's really easy to mix up these numbers, or x and y, and put them in the wrong spot, so make sure you're paying attention to that. Y is 2, x is negative 1, so we have 2 equals negative 4 plus 6. Negative 4 plus 6 is 2. That does work. The first equation is true. Alright, and then we'll try the same thing here. X is negative 1. 3 times 2 minus 5. So 3 times 2 is 6. 6 minus 5. Actually, 6 minus 5 is 1, and that is not negative 1. So those are not equal. It does not work. And remember that the ordered pair has to make both equations true. It only made the first one true, so it was not a solution of our system. Okay. All right. So now let's go down to solving systems by graphing. All right. And essentially, what we're going to do, if you can graph, you can solve a system by graphing. We're going to graph two lines on the same plane. Okay. Where they intersect will be our solution, because where they intersect, that coordinate will make both equations true. Okay, so this first one's set up really nice for us. We have both of them in slope-intercept form. Okay, and that's the form that we really like a lot. So we have y equals 1 half x minus 5. We're going to graph this. Okay, the first thing that we want to do, actually I'm going to list these steps to follow so that we can follow along and see that I'm following them. First thing, we want to put it in slope-intercept form. Okay, we know a few different ways to graph, but as I was saying during the graphing chapter, slope-intercept form is really where we want to be, because that's where we should be most familiar with and where the least mistakes will happen. Okay, so for this first problem, we have them both in slope-intercept form already. We're good. Alright, then we will graph each line. So I'm going to graph this first one. I have x minus 5. Negative 5 is my y-intercept. That's where I'll start. 1/2, that means I rise 1, run 2. Rise 1, run 2. Okay. I will use, hopefully, a different color marker to do the other one. Nope, I don't have a different color marker. Oh, yes I do. Look at that. Alright. So, my second line, I have negative 3/2 x plus 3. Plus 3 is my y-intercept. Be there. Negative 3/2. I'm going to make sure I move this negative to the top. So I go down 1, 2, 3, run 2. Down 1, 2, 3, run 2. Okay, and so I see where they intersect, but I'm going to draw my lines. Okay, and this one intersects at a pretty nice spot where they both run into it. Pretty easy to see. Okay, and so this point, I guess now we're talking about what our third step is. Identify the intersection. Identify the intersection. Okay. And then name the solution. Okay. And so in this case, our intersection is here at 4, negative 3. And if we wanted to, we could plug in 4 for x and negative 3 for y, and we'd see that that makes both equations true. Alright? If you look at the next example, you'll see that it's pretty much the same. The difference between the first example and the second is that in our second example we have a line that is not in standard form. Now, like I said, we know plenty of different ways to graph. We can do standard form. We can do slope-intercept form. We can even do point-slope form. I saw some people doing that, using that, even though we didn't go that deeply into it. But slope-intercept form is what I would tell you if you have any difficulty graphing. Get it to slope-intercept form, and what that means is get y by itself. So let's do that for this first line. We already have it. Y equals negative 2x plus 4. So we'll start at 4, go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. I'll do that till I run out of space, which I just did. Alright, my second line, I'm going to make sure I put it in slope-intercept form. So I'm going to solve for y. I'm going to subtract 3x from both sides, and I have negative 2y equals negative 3x plus 6, and then I'll divide by negative 2, and so I'll have y equals 3 halves x, because negative divided by negative is positive, minus 3. Again, because positive divided by negative is negative. Alright, so I'll start at negative 3, 1, 2, 3. My slope is 3 halves, so I'll go up 3, 1, 2, 3, over 2. Up 3, 1, 2, 3, over 2. Okay, and so here are my lines. Try to make them straight. The important part here is this location though, and that is at 2, 0. That's my solution. Notice how we're writing our solution as ordered pairs. Continue to do that. Flipping to the back side. We will have to deal with some special cases here. Just as when we're solving equations with variables on both sides, sometimes we'll see some problems that just aren't as clean as one number and one solution. So let's deal with this first one. Have y equals 4x minus 3. Negative 3 is my y-intercept. 4 is my slope, so I'll go up 4. 1, 2, 3, 4 over 1, do that again. 1, 2, 3, 4 over 1. Alright, first line, first done. Second line, I'm going to make sure I put it in the slope-intercept form. So I'll add 8x to both sides. So I have 2y equals 8x plus 8. I'll divide by 2 to get y by itself. Y equals 4x plus 4. Alright, so my y-intercept is at 4. I would go up 4, but I don't have space, so I'll go down 4, 1, 2, 3, 4, and then to the left 1. Down 4, 4, and to the left 1. Alright. Okay, and now I will go straight line, try to be straight line, and then I will go same thing here. Alright, those are my two lines. Okay. Alright, so what do you notice about the first system? What do you see what happens? Hopefully, you see that the lines don't intersect. Lines are parallel. Alright, so if you remember what we talked about, how we saw by graphing, we want to identify the intersection. If the lines are parallel, that means they don't intersect. So, where's the solution? For this, you see there's no solution. There's no solution to the system. There's no point that makes both equations in the system true at the same time. Alright, let's look at the second problem. Okay, I'll do this first line in red. So we have y equals negative 3x plus 1. 1 is my intercept. Negative 3, so I'll go down 1, 2, 3, and to the right 1. 1, 2, 3, and to the right 1. Remember, I could also go up 3, 1, 2, 3, and then to the left 1. Okay, and that's that line. Okay, try to keep it on the same line. Alright. Alright, the second line, remember I want to get it in slope-intercept form. That's where we make the least mistakes. And so I will try to get y by itself. So 3y equals negative 9x plus 3. Then I'll divide by 3 on both sides, and I get y equals negative 3x plus 1. And hopefully you see these are the same line. Okay, I could draw this on top of it, but I'm not. Okay, so what do you notice about the second system? They are same equation or same line. Okay, and so you might say, well, there's no solution. They don't intersect, but there actually is infinitely many solutions. Since they are the same line, they intersect everywhere. Okay, I could draw this other line right on top of it, but that would be redundant right now, since we know that's going to happen. Okay, this has infinitely many solutions. Okay, so these are our special cases, in the sense that usually when we graph it, we see the intersection, and then that's our solution. In these two cases, first with the parallel lines, there's no intersection, and so there's no solution. And in the second case, they're the same line, so there's infinitely many solutions. Okay, so here's how we can summarize that information from these notes. Okay. Okay, if there's different slopes, the lines intersect, so there's one solution. If the two lines have the same slope and different y-intercepts, okay, essentially they are parallel. The lines are, oops, I should have said parallel here, parallel. So there are no solutions. Parallel, they don't intersect. If they don't intersect, there's no solution. And then finally, if they have the same slope and the same y-intercept, the lines are the same, so there are infinitely many solutions. Okay, alright, so that's solving systems of equations by graphing. Remember, if you can graph one line, you can graph two lines. If you can graph two lines on the same graph, then you can solve a system by graphing. Okay, here's a summary of that. Alright, Good luck.